Did you know that your phone only understands two numbers, 0 and 1? Yes, everything here is in binary. Taking a photo, for example, every pixel in this photo is made of binary. The camera doesn't see color. It sees some things like 1100, 1100, etc. And together, millions of these tiny binary codes create the full picture. Even sending a message to your friends is using binary. The word hi may look normal to us, but to your phone it's like 0, 100, 100, etc. Just a bunch of zeros and one is flying around. Inside your computer chips, billions of microscopic switches flip between on and off. When on is 1 and off is 0, that's literally how your apps run, how your video play, or how you scroll this TikTok video right now. So, next time that you say your phone is small, remember, it's basically doing everything with just two numbers, 1 and 0. Binary runs the world!
Combinational vs sequential circuits. From vending machines to login systems, digital circuits are split into two core types, combinational and sequential, that underpin daily tech like vending machines and login systems. Combinational circuits produce outputs solely based on current inputs, with no memory of past signals. A vending machine uses them to calculate inserted coin values, compare totals to item prices, and instantly dispense goods if the amount matches. These circuits act like real-time calculators, relying on logic gates for immediate, input-driven responses. Sequential circuits, by contrast, depend on both current inputs and stored past states, enabled by memory components like flip-flops. A login system uses them to retrieve saved credentials, past state, and compare them to current password inputs. They also track failed attempts, updating their state to enforce security locks over time. The key difference is feedback. Combinational circuits lack it, while sequential circuits use feedback to retain state. Together, they enable smooth digital interactions. Combinational circuits handle instant decisions. Sequential ones manage context, forming the foundation of modern devices.
In the 1930s, the birth of the computer spurred the initial concept of chips. In 1958, the world's first integrated circuit was successfully developed in the United States, officially ushering in the chip era. In the 1960s, advancements in semiconductor technology and the discovery of Moore's law led to a greater focus on modularizing chips compared to single chips. Modular chips improve system maintainability and development efficiency. From the 1980s to the 1990s, the widespread adoption of personal computers and the rise of the internet intensified the demand for chips in terms of both quantity and performance, driving the evolution of chips from the micrometer to the nanometer scale. This also enabled chips to be used in more fields. In the 20th century, the rapid development of the internet, big data, and artificial intelligence presented chips with both opportunities and challenges. Modern computers have made leaps and bounds in computing power and performance, and are now used for more than just simple computing, such as video production and video games. This is all thanks to the modular sophistication of chips.
almost 5 decades, semiconductor industry prospered under the rule of Moore's law, driving the transistor to double its density every 18 to 31 months. This process led to chip makers' company making even more powerful monolithic chips. However, the story is not always full of happiness. Advanced process nodes became extremely expensive, while thermal management is getting difficult to control. And mostly new demands such as AI, 5G, and automatic vehicles are growing. That's when we lead to chiplet, a breakthrough that can hold customization according to the market's needs. Now let's turn our camera to the professionals.
Hello, my name is Li, tech news reporter, and I am here today with Professor Liu and his assistant, Mr. Shi, who can help us to comprehend better how chiplet becomes what it is nowadays. Could you please explain to us the benefits of chiplet technology?
Of course, let's talk about why chiplets is such a big deal kept of the single chips, starting with the stuff of the matters most, cost and fixed label. We all used to think bigger is better for single chips, right? But here is the catch. The larger of the single chip gets, the more its cost. And fixing or replacing them hits so well hard. Even small problems on the single chips can make the home seem useless, which is a hard waste of the time and the money for the big companies.
So, the main purpose of chiplet technology is to modularize chips. As for how chips modularization brings so much convenience to the people, could you explain it a little?
Game here. It brings the chip into smaller model, which lets companies present the processors way better. For example, they can use different production process for the different models. It means no need to make the wall chips with the most wanted found expenses. It not only does reduce the risk and also cut down the R&D cost a lot, since teams don't have to start from the single every time or then want to update the function.
Thanks to Mr. Liu for the explanation. I think we all understand the epoch-making role of chiplet technology in the development of chips. So, what plans do the developers have for the future? Let's invite Mr. Shi to explain the future for chip development.
2025 to 2028, AI first validates the tech, split AI chips into small chiplets to solve the large die, high cost issue. AMD and NVIDIA are already working on this by 2027. The market will hit $45 billion and the modularization foundation will be proven. Starting 2026, adoption in automotive consumer electronics. First, automotive. By 2030, half of cars will use it, cutting costs by 40%. Upgrading to L4 only requires swapping the NUP chiplet. In terms of consumer electronics, by 2028, phone LCS will be 25% cheaper and AR glasses 30% lighter. In 2035, it's become chip Lego. 80% of chips will include chiplets. There will be a chiplet digging, and AI will turn into configurable chiplet receipts. Ultimately, all devices will get AI-level computing power at low cost.
Thank you for your explanation, sir. I wish all developers success in completing their plans and making greater contributions to the progress of human society.